Today we are going to discuss about the next type of distillation, that is distillation under reduced pressure or vacuum distillation. It is distillation under reduced pressure. This type of distillation is used for purification of high boiling liquids, and those which decompose on or below their boiling points. Applied for those type of liquids which are having high boiling points, and those liquids which decompose at or below their boiling points. So if a liquid will decompose at its or below its boiling point, then will not be able to separate it by distillation, because when we will be doing the distillation, what will be happening, the liquid will start boiling at its boiling point, and then before that it will be decomposed means it will break down further. The original liquid will not be there. So this is the reason why we use vacuum distillation, so that we can separate those liquid which have high boiling points, and before their boiling point comes they decompose, means they break down, or they will form another type of compounds. Now what is the principle involved in the vacuum distillation? We will be seeing that principle which is involved in vacuum distillation. When pressure is reduced, then the boiling point of a liquid also reduces. We can say pressure is directly proportional to the temperature. As we will reduce the pressure, pressure is reduced, then the temperature, that is the temperature at which the liquid boils, or the boiling temperature, that also will decrease. So now due to this, the liquid or compound which has high boiling point will start boiling at low temperature. And due to this, there is no decomposition of that compound, and it will be obtained easily without any decomposition. So this is the principle involved in vacuum distillation. We will see the apparatus arrangement, then it will be easy for us to understand how the pressure is being reduced in the apparatus of the system. This is the capillary that regulates the airflow. Here a thermometer is introduced, and from here it is connected to a condenser. This is the viii condenser. From here there is an outlet of water from where the hot water goes to the sink, and this is the inlet, it is the cold water enters. Then further this is sent to the receiver where the distilled liquid is collected. This is the arrangement of the apparatus in the vacuum distillation. Now this receiver, it is attached with a vacuum pump, due to which there will be created vacuum. This is the connection to the vacuum pump. Here it is connected So this is the arrangement of the apparatus. In this there is present the mixture that is to be, from which the components are to be separated, and here we obtain the distilled liquid. Now we'll name, this is the capillary to regulate air. Okay. This is having a stopcock over here, okay, which is helpful in regulating the air. Okay, so this is the stopcock over here. From here the cold water is sent in, so cold water inlet. Okay. This is the hot water outlet or to the sink. Then this is the distilled liquid, which is collected when the vapors pass to the condenser. This is the vacuum pump. So this is the arrangement of the apparatus. Where the change is made, there is a insertion of a capillary tube, and from the receiver there is a connection to the vacuum pump, which controls the pressure of the round bottom flask and the reduced pressure, okay, is maintained. Now the liquid boils at temperature lower than its boiling point, okay, and hence gets separated without decomposition. Now in this case we will see some examples which will make the picture more clear. Some examples like glycerol can be purified and can be distilled under 12 mm Hg of pressure at 453 Kelvin. Although it is having boiling point of 563 Kelvin, okay, at normal pressure, or you can say at atmospheric pressure, that is 760 mm of Hg. But when glycerol is boiled at this temperature, then glycerol, it decomposes, okay, it decomposes, and we will not get the glycerol, we will get the decomposed products. So to prevent this, what we do, we lower the pressure, okay, pressure is lowered, and pressure is lowered up to 12 mm Hg, and now the liquid, it boils at 453 Kelvin, and hence it will not be decomposed at this temperature, and we will be able to obtain it. Now for general cases, when we talk about what is the range of pressure we can keep and how we can maintain it, that is a pressure of 10 to 20 mm Hg can be obtained by using a water suction pump, and temperature can be reduced by 100 degrees Celsius, okay, and pressure up to of 0.1 mm Hg can be obtained by using a vacuum pump, thereby reducing the pressure, the temperature further. Okay. So this was the mechanism of the distillation under reduced pressure. Now we will see what is steam distillation. The next type of distillation we are going to study, it is steam distillation. So this method is used for separation and purification of organic compounds from non-volatile impurities It is useful for those type of compounds which are volatile in steam and are insoluble in water. Only those type of compounds can be separated. Okay, which are volatile in steam means when steam is passed through them, steam has like lot of energy in it. It has high temperature. So these compounds, they will be volatile in steam, means they will form vapors. Okay, and with the formation of vapors, what will happen? They will be getting separated. Secondly, they should be insoluble in water. That is, these compounds should not be soluble in water. If they will be soluble, they will not be easily separated, and this method will not be useful for them. Okay, the principle governing steam distillation is that each component will exert its own pressure, and the vapor pressure of the whole system will be the total vapor pressure of these two liquids. So in this way, what will be happening? We will be reducing the boiling point of the particular liquid which is to be separated. We'll see how it happens. Before that, we'll just take a quick view of the principle. The mixture, that is mixture of organic liquid and water, is heated. Each of these components will exert some vapor pressure. Suppose vapor pressure of organic liquid is P1 and that of water is P2. So the total vapor pressure, that is P of the system, will be P1 plus P2. Now the liquid will start boiling at this pressure, that is P. Okay. Now we can see that the partial pressure of the organic liquid, that is the vapor pressure of the organic liquid, it is less than the total vapor pressure. Now the vapor pressure of the original liquid, that was lower than the total vapor pressure, and due to this, what will happen? The liquid will start boiling at a lower temperature. So organic liquid starts boiling at temperature lower than its boiling point at atmospheric pressure, and hence decomposition of the organic liquid is avoided. The procedure, what we see, that steam is passed. Okay, for that there is a steam generator. We'll see the apparatus arrangement. From here it is heated and the steam is rising, and here the steam gets rise and it passes into this round bottom cloud where there is present the here also this is heated and the steam which is entering, it will provide energy to the system, means there will be heat in the system, and this heat will be making the liquid vaporize, as it will be volatile in steam, so it will vaporize and then it will pass through this tube into this condenser, and the Liebig condenser is having a water inlet and outlet pipe. This is the water inlet pipe, okay, and this is the water outlet pipe. This is the condenser. Here the pure liquid is there, so this is the distilled liquid, and there is the water also in it. This is the organic compound plus impurities plus water. Some examples of which show this type of distillation. Examples of steam distillation are: first is mixture of nitrobenzene and water. Separated nitrobenzene normal boiling point is 483 Kelvin and that of water is 373 Kelvin. But when they are separated with steam distillation, we'll see that the mixture boils at lower temperature or lower boiling point than either of these two. Okay. That is at 372 Kelvin. So at this temperature, this mixture will start boiling. Another example you can see is of mixture of water which boils at 373 Kelvin and aniline which boils at 457 Kelvin, but their mixture will boil at 371 Kelvin. Okay, so in this way we see the temperature of boiling is lowered, okay, and so the mixture starts boiling at a much lower temperature because of the pressure. Okay, as the pressure is reduced over here also, we'll see that the boiling point also reduced. Now at the end we see that the organic liquid and water is obtained in the receiver, so that can be separated by separating funnel, or simply you can keep it standing for a long time. You will see that the two separate layer will be formed, okay, water and the organic liquid, and then we can decant off the layer which is at the top. Okay, if in this way the two water and the distilled liquid can be separated.